Good evening. My name is Sharon Sandman. We welcome you and want to thank everyone for joining us this evening. Just to go over webinar logistics, webinars will be recorded and will be posted on NAPS and Southwest Climate Hub websites. NAPS and Southwest Climate Hub YouTube and NAPS Facebook. During the presentation, you may enter your question and answer box or in the chat box. After the presentation, we will have a question and answer session. That time, you can also raise your hand to ask your question. The Drought webinar series is a collaborative effort with our guest speakers, Drought Learning Network, Native American Producer Success Project, and Southwest Climate Head. This evening, Dave DuBois, New Mexico Climate Center, will be sharing information with us about CoCoRaHS Network. The Native American Producer Success Project is a collaborative effort between developing innovations and Navajo Education Incorporated, New Mexico Cooperative Extension, and Dene College Land Grant Office. The goal of the NAPS project is to increase the profitability and long-term sustainability of Navajo farmers and ranchers by providing information about improving Navajo farm and ranch operations, increasing Navajo farm ranchers' knowledge of and access to available programs and technical assistance provided by the USDA, BIA, Navajo Nation, New Mexico Cooperative Extension, Dene College, and Land Grant Office, and others. We are strengthening the organizational capacity of the Navajo Farmers and Ranchers Congress to address the current and future needs of Navajo farmers and ranchers. NAPS is funded by the USDA Office of Partnership and Public Engagement, Outreach and Assistance for Socially Disadvantaged Farmers and Ranchers, and Veteran Farmers and Ranchers Program. At this time, I will turn over to Helena Deswood.
Hello, everyone. Just a little background about Climate Hubs and the Drought Learning Network. USDA Climate Hubs are a unique network of 10 regional teams located across the U.S. The Climate Hubs link USDA research and program agencies to deliver regionally relevant, timely, and science-based tools and information to agricultural producers and professionals. The Drought Learning Network links climate service providers with resource managers to increase landscape and community resilience in current and future drought. Go ahead, Sharon.
Okay, thank you, Helena. At this time, we will turn this over to Dave DuBois.
All right. Yes, Sharon, thanks for that introduction, and I will start to share my screen. All right, let me start my clock here. Okay, so we're going to talk about the Community Collaborative Rain, Hail, and Snow Network. So if you were with us last time, Mike Crimmins gave a great talk on another program that collects precipitation, and both of these are collaborations. This program does the same thing. It goes to a different database, a national database, and so I'll talk about that. And so the purpose of this talk is to give you an overall of what CoCoRaHS is, and then how to start to get set up and after this presentation, you should be able to go, if you're interested, go on the website and sign up and become a member of CoCoRaHS. So, all right. So what is CoCoRaHS? It's a crazy name. So who are we and what do we do? So it's a grassroots, nonprofit, community-based, high-density precipitation network. So as you can see from the pictures, it's all volunteers and just all walks of life, all ages. And our goal is to put together and collect precipitation. So we collect anywhere we can in our backyards, our front yards. Some people have them on ranches, several gauges, and we collect rain, hail, and snow. We don't do temperature, but we focus in on precipitation. So this is our website. So it's the CoCoRaHS, and it's CoCoRaHS.org. You could put the www or leave it out, either way. But this is, I did a screenshot of the website this afternoon, and that's a picture of all the observers. So every little dot you see there, let me turn on my highlighter pen so I can show you. So all these little dots in this map are individual observations, like people, you and me, to submit their precipitation. So as of this afternoon, there were 9,765 observations that were submitted to CoCoRaHS. And and the colors are by the amounts. And it looks like the highest in the US was 8 inches. So that's a lot of rain somewhere in the US. And we actually had some precip in New Mexico. So that's our website, and I'll talk more about it in a minute. Okay, so our aim, so what do? We collect precipitation, but our aim is to provide the highest quality data for various different users. I just included a few: natural resources, education, research applications. And you probably have seen maps that show precipitation over the Western US. And some of those maps are actually use CoCoRaHS to make the maps more accurate. So our program supports other climate and related applications and mapping. And so this data is not just to make pretty maps, but it's actually used to collect the climate record over time. So this is a one way to get the data into something useful so that water managers can use, and it goes into the national database. So this is a public data. So once you submit your data, it becomes part of the CoCoRaHS system, and it becomes available to other users, and in other users, for instance, make maps of precipitation on a daily basis and then on an annual basis. Okay, so the rest of this talk, I'm going to be very practical and talk about, so what kind of things do you need to do to sign up, and what are the things that we require of users? So there's two things. I'll talk about what we will need from you, and then I will explain what you will need before you can participate. Okay, the first thing is all of our applications are online. It's through CoCoRaHS.org. On the upper right corner of the web page, there's a sign up, and once you click that, since we are actually several nations in Canada and US, you select US, and this form will pop up, and all you have to do is fill it out. And so you need to know your location. So we need to be able to put a dot on the map. So and there's ways we can do that we can always follow up with you on ways to get, not because some people don't have a street address. Some people do, but if you don't, you'd still get a latitude, longitude fairly easily. And then the third thing is a commitment to collect accurate scientific data. So that's that guy there in the bottom left. He's the guy who came up with CoCoRaHS, and it actually started up in Fort Collins back in 1997, and then we started collecting data in 1998, and that's how CoCoRaHS started, through a flood. And it's just to show you him saying he's going to collect good data. And then lastly, we do communicate with observers a little bit. So we don't send out a lot of emails, but we do send out a newsletter, and occasionally we'll do outreach in webinars and things like that to kind of keep up to speed on CoCoRaHS. So that's all there is need from you. Okay, things you'll need to start collecting. So if you go on the website, you'll sign up, and then once you sign up, you'll get a station number and a station name. And for instance, I just chose one in Doña Ana County, but it could be any county in the U.S. You'll get an NM, New Mexico, DA is Doña Ana, and then a number. That's the sequential number, how many people have participated in that county, and then you also get a station name. And then there'll be some training. If you need more training, there's on the website. And also it really helps to have a desire to help out, to be a volunteer, study and learn about storms. You'll learn a lot if you participate with us about collecting data, as well as looking outside and looking at the rain, hail, and snow. And then we'll have, like this, be suffice for a training. And also, once you get online, this will be your interface to log into the website, to log in, to enter your data in. So you'll get all that if you sign up. You'll get a username and password, and that'll be yours. You can put it on we actually use cell phones as well as a website. So on a daily basis, this is all you need. So on the left is the rain gauge, and I actually have one right here. So it's very, very simple. It's just a plastic rain gauge with a funnel and then an inner and outer cylinder. And so you'll mount that in your backyard or front yard. And I actually have I brought one as a prop here in my room. So this is basically a 4x4 piece of wood. It doesn't have to be exactly like this, but it's sturdy. It doesn't blow over. And you can mount the bracket on the side here. I put some screws. So that's all you need to do. And you can mount it on something else. You can put it on a T-post as long as it doesn't wiggle and break off. And it's about, and this is the 4-inch gauge, and we really required users of CoCoRaHS and volunteers to actually get the same gauge, because we want to make sure that the information comes from the same type of gauge, and because we know there's lots of different gauges out there. So it's best if you get one of these if you're gonna join CoCoRaHS. And right now, these are about $40, including shipping. There could be some other opportunities. We can talk about that after the talk. And then the second part is somehow to connect to the internet, either through a desktop computer, laptop, or a cell phone. And this is we have a iOS and as well as Android app that you can enter in your data on a daily basis. Okay. So, next section, we'll be talking about how to set up your gauge. So you got a gauge like this, and it's okay. I need to set it up. I need to install it somewhere, and then we'll talk about how to measure, and we'll talk about the other parts of precipitation, not only liquid but hail and then snow. Okay, the important thing is location is very important, just like Mr. Elk saying here. It's the key to good data. Okay, so avoid placing it where there's going to be sheltering. Basically, if the wind blows, if it prevents the rain from going into the gauge, avoid any structures. I would avoid putting it near a house, even though it's very convenient. But I would get it away from the house, at least twice the height of the house away from the building. And then just be cautious about trees and things like that. If you put it under a tree, sometimes it'll the tree may drip for a while and it'll enter in false precipitation, or it may shelter it, prevent from snow or rain from entering the gauge. So there's a couple other things, that you just got to kind of a little bit of humor here. Sprinklers, you don't want to put it right near a steep slope, and then also be wary of animals. So we got to have it at a certain height, and then you never know what can come up in your backyard, mountain lions or bears or something. Okay, so one idea is to put it on the fence. However, if it's a solid fence, the wind will kind of blow over it, and it creates this slipstream, and it actually will cause updrafting. And actually the wind will, just like if you're driving a car, you can actually put your hand out, you can actually feel the wind blowing over and blowing into it. So the wind kind of pushes the drops away from the gauge as it goes over it. So if you want to use the fence, that's still fine, but you want to have it above the fence. I would say if you can get a piece of wood, screw it on so that the gauge is maybe maybe 8 or 9 inches above the fence and maybe a foot above the fence. I mean, it's a good place. It's nice and secure, but you want to be careful of having it real close to the fence. You don't want to have it the same height as a fence. That's what you're saying. So ideally, you want to put it away from buildings. So here's an example of an excellent siting. We used a little stand like this, and you can put it anywhere. This is pretty heavy. It's about 20 some pounds with a 4x4 and then 2x4s on the base. It's pretty easy. These are really easy to build. You get some scraps. They're only like 20-inch scraps, and you can screw those on, make a nice, and then put bricks on it if you want to. That'll hold it down. It's not going to blow away with that. So, and then you can move it if you need to. So if you have if you're confined to a certain area, you want to put it, if you have trees, if you have some like big cottonwoods, that's still okay. But you want to find an area, if you look up and find out where area, kind of think like a raindrop. And where is the raindrop going to go if it comes down? So you want to have something that's equidistant from the nearest big trees. You still can get good data even when the trees are around you. It says that you may get less precipitation when the winds are blowing at an angle, in the same way with snow. But we'll take whatever data you can give us, even though there may not be a perfect place, and it's rare to find a really perfect place, but you do the best you can. And so about the heights, we suggest around 2 to 5 feet off the ground. So that's about the height of the top of the gauge. So why do we choose that? So it depends on if you have, depends on how deep the snow can get in your area. You don't want the snow to be higher than your gauge. If there's no snow where you are, then you have to worry about animals. If you have kids or animals that walk around, they could bump it and fall off. And these are made out of plastic, so you don't want something to be bumpy, because these could break if they fall off, especially if it's on soil, on rocks and things like that. So that's why we chose it a higher, maybe 5 foot. You don't want to put it too high, because the winds actually increase as you go off the ground. And it's basically, the technical term is it's a logarithmic increase as you go up. And if you know what that means, you'll say, yeah, that's important. So you want to have it as low to the ground, but not too low, so that it'll get messed up from something walking around on the ground. So we suggest somewhere around between 2 to 5 feet. And so you want it sort of level. And the reason why, and we also like to have a angle on the side, just like I did my gauge here. And I just did it. I just got a Sawzall and cut it off. The reason why we do that is basically it prevents splash into the gauge. So say the rain's coming down here, it hits that, it's gonna deflect off. So if you had it flat, it could splash and then come into the gauge. I mean, it's not real likely, but it could, when it's raining really hard, it could splash up. And you can try that. Just drop a bunch of drops on something and you can see the splash go over, and you could add another hundredth or couple hundredths of an inch just from that. So that's why we have an angle on there. And it's good to have, you don't need to be crazy in terms of how horizontal it is, but it's good to have it level. So let's get into how to measure rainfall. Just a nice picture of rainfall across New Mexico here. So when should we read our gauges? So the worldwide collection time is in the morning. So in the morning is different, right, for all different time zones, but it's the local 7 a.m. is the standard time for collecting of actually all the weather if you're doing a volunteer network. However, we have a window which is still acceptable, but between 5 a.m. and 9 a.m. So other times are accepted too. If you can't make that time, if 10 o'clock only works, that's great. But when we make our maps, we only use the data from that morning time. I know we've got several people who have shifts work, So they can only report it at 6 p.m., which is great. I'm glad they do that. However, it won't be part of the maps that we see on the website. So 7 a.m. is the preferred time, but we're totally flexible on that in terms of when we accept data. So reading the gauge, so it's pretty easy to do. And the important thing is accuracy and consistency are the importance for us, because we rely on observers to do their best so that we can use the data for creating climate maps and drought products. Like we use these for the U.S. Drought Monitor, and we create layers that we look at. So how long has it not been raining in a certain area as opposed to how much has rained. So so I'm going to talk a little bit about some different situations that you may find. Okay, the most common observation in our area is a 0, zip, nada, nothing. So the gauge is going to be empty, and it'll probably over time, if you're an observer, you'll probably measure more likely dust and bugs on your rain gauge. So you'll want to be able to clean that out. But your most common observation in the West is going to be 0. So 0 is data, right? So we want to, even though there's no rain, we like to actually have a data entered of 0 if it's not raining, because if you don't put data in, it'll say not available. So we don't know if it actually rained, or you're away from, it didn't rain, or if you're away and not there. So we really prize and treasure those zeros that are officially zeros that are not there. So it's real important for the network to know that it did not rain. It's very important that it rains, but we need to report the zeros, because we use this product for using it for tracking drought. And drought is, how many days that we had without rain. So we need to have those zeros when we put them into our system. The second one is if it just has just a little bit of rain, just a few sprinkles. You've seen it before. You see the drops come down on the ground. You just see, like, you can count them on your hands, right? We call that trace. So really, there's no accumulation, but we know it rained, and it won't go into any totals. But we know it did rain, so we call that trace. So for instance, like you took a measurement in the morning, and then at 3 p.m. or 4 p.m. we got a few sprinkles, but by the time you read the gauge in the next day, it had all evaporated. Poof, it's gone. But you did remember that it sprinkled yesterday afternoon, and even though you didn't register it, you didn't see it during the next morning, put a T there anyway, because that'll show us that it actually did. There was some precipitation, but it was only just a few drops, just like this picture shows, just a few little drops. Okay, the third thing is we get this thing called a meniscus. So I actually have my gauge here, and this is a brand new gauge, so there's not a lot of meniscus in. I actually preloaded up with a storm. I created a storm in my house here. And so meniscus is basically the surface tension. It pulls the edges of the water on a surface here. It actually makes like a bowl. And so what we do is, to be consistent, we read the bottom of the meniscus. So whenever because it's kind of like a bowl like this, we don't read the top, but we read the bottom of it. So in this example here, you can see, so this is the 0.2, and this is 0.21, 0.22. So the answer in this one would be 0.22. If you took the top of the meniscus, it would read 0.23. So there in some cases, it actually could, you could inadvertently add 1/100 of an inch every time you take every time you take an observation. So we want to be able to be consistent and take the bottom of the meniscus. So 0.2, 0.20, 0.21, 0.22. That would be the answer here. Okay, so I don't know if you can see this or not. Can you see? This is an experiment to see if I can. Let me put it close to my face so it can register here. So if you can type in, if you can see that, type in the chat. What would be the answer to that? How much rain fell? Can you guys see that? Okay, What's your guys' answers? So Helena or Sharon, is there any? I don't see any chats. Do you guys see any?
Yeah, there's some inputs. 0.44 inches is one guess, and then another 0.35 inch.
Any more?
Those are the only two I see.
Okay. Well, let me do it one more time. And let me see if I can get my camera to focus. There we go. If you can see that. I don't know how close you can get to it, but I would say it's about 0.44. It's right on the edge there. The top of the meniscus is at 0.45, but the bottom is sort of in that 0.44. So that's and sometimes I have to put it up in the sun to see it, and then put your eye right level with it. So that's the hardest thing that we have to do when we take measurements is read that line, and it's your interpretation and experiment with it, and so we really treasure all the values that you guys get, but it's real important that the right numbers are entered. So like for instance, there's a big difference between a 0.4 and 4. So probably the most common mistype of calculation and entering data is moving the either putting a 0.4 or 4 or something like that in the data. It's that it's getting that right. So there occasionally could be times when you get a really heavy downpour, and this is what it looks like when I just put that one back in. But there could be times when this inner cylinder, this is your measurement cylinder. This here only just stores in case it overflows. So on the top of this, it goes all the way up. It starts at 0 and it goes all the way to 1 inch. You probably can't see that, but it says 1.00. So if we get a really heavy storm, it's going to actually overflow. There's a little notch in here. So it's going to overflow and empty out into this bigger cylinder here. And so we can actually measure more than 11 inches of precipitation. I know we won't get that in New Mexico, but it'll spill out and it'll start to fill up on the outer cylinder. So in that case, so we can do is we actually, remember, this is just the storage, this one here. So what we do is we'll keep measuring, we'll pour in we always use the funnel, and we'll pour in whatever is in here and just measure, and then write it down, and I usually put it on a piece of paper and add it up. So this is an example here. So if the measurement is more than 1 inch, meaning that this cylinder is filled all the way to the top and there's water sitting in here, you'll need to do a few things. So you first measure what's in the inner cylinder, and then you pour out whatever's in there, and then you'll start pouring in whatever's in here into here, and then you just add it up. So that's what this is showing you. So Nolan, he's showing us this. And then you keep doing that. You measure, you always use this as your measurement. This is because this is the only thing that has the little lines on it, that has numbers on it. This doesn't have any numbers on it. So this is just the storage. So you'll add it up. Like for instance, this one here, an example here I show. The first one was 1 inch, filling up this whole thing at once. And then we had a 0.97, a 0.88, a 0.92. And if you add that up on your calculator, it comes out to be 3.77 inches. So that was the rainfall. And that's what this is in this gauge in this example. The total was 3.77 inches. We're likely not going to get something like that in New Mexico. It's possible, but most of the time you may get like an 1.5 inches or occasionally a 2 incher, but usually not as much as 3 inches. But so I maybe a couple times a year, maybe 3 or 4 times a year, I may get the inner cylinder to spill over, and I'll have to do this. Depends on where you live. If you live in an area that has more precip, you're going to get more chances of having to do this procedure. But that's probably the hardest thing in terms of rainfall. Okay, the next part, we went over measuring precipitation liquid. So we also measure hail. So this is a picture from El Dorado of some hail falling down. So it's important to get hail because that's one of the things that we don't have a lot of information on. So if you see hail coming down, first thing I do is look on my cell phone, like what time is it, or look on your watch and remember that. So, oh yeah, it started hailing at 4:30 p.m. and then make a mental note of it or write it down. And then there's a way you can enter it into our CoCoRaHS website, and that data is be really useful, particularly for the National Weather Service. They need to know if hail is coming down, because a lot of times the areas that have hail are sometimes they're far away from the radar, so they don't actually see what's going on, especially in the Four Corners. There's really no good radar coverage for that area. The radars overlap from Albuquerque, Flagstaff, but the radars are pretty far from, as we all know, Albuquerque is pretty far from the Four Corners as well as Flagstaff. So the radars are pretty high up in terms of where the beams go. So we really rely on observations to tell if there's actually some hail coming down. So this is actually the form. So once you become a member, you'll have a way to do this. You'll click on your enter my reports, and then there's actually a link called hail, and you could actually, and this is actually the form just kind of zoomed in. So this is you'll enter in the time when the hail started, and then the sizes of the hail, and we have some guidance on it from rice, pea 3/8 of an inch, grape 5/8, penny, nickel, kind of easy to see. Get something in your pocket to look at. Is it pretty close to a penny or a nickel? And all the way up to golf balls, etc. You probably won't get any of those in New Mexico. Those are more of in plains. But these are your guidance here in terms of the smallest, average, and largest. And these are estimates. There's probably a variability. So do your best. And then the important thing is how long it lasted. So how many minutes? So important is when did it start, and then how long, and then what sizes. Those are the critical things that the Weather Service, if you only have time to do that, do those, hit submit, you're good. If you have more time, there are other descriptions about, is it soft hail, when, did it rain before or after the hail? Those are great too. But if your time is precious, or you're there, or you're driving and you stop, use those as a guide, the time, the size, and then how long. And then also, especially if you're not at the place where you normally take your measurement, you'll need to put that in to the there's a text box, and you can actually put that in. Okay, we got rain, hail, and the third one is snow. So this is the time of year when we get to practice our snow. So we have two things that we do for snow. We measure the liquid content of the snow, and so we get a gauge. So this is actually my gauge from my house. It's kind of all old. It's been outside since 2011. So I just take off the funnel, and then I just wait for the snow to fall into the gauge, and then I melt it, and that's the liquid amount of the gauge, how much is fallen into my gauge. So we report that as the precipitation. So if that's the only thing you do is just to melt that, that's great too, because at least we know how much liquid, because that's the important part. It's nice to have the depth, but as we all know, the snow to liquid ratios can vary by quite a bit. Sometimes, some people say there's about a factor of 10. It can be high as 30, or it can be as less as 5 or 4. It depends on the temperatures, the size of the crystals, the orientation of the crystals, things like that. So we can't make an assumption that you can just use the 10, the liquid to snow ratio. We really need that liquid content. So you melt it, and I'll show you some tricks here. And then the second part, if you have time, is to measure the depth. And so Nolan here is on the bottom right. He's showing you how to do that. And this is a picture of Fort Collins here. So we measure how deep the snow is. But if you don't have time, just do this one and then estimate the snow depth. So, okay, so what are the tools? Well, you get a ruler. So a yardstick, that's perfect. We measure it to the nearest 1/10 of an inch. You don't have to have a 1/10 of an inch ruler. I don't have one. I just use a regular yardstick, and then I round up to the nearest 1/10 of an inch. And then the second one, it's not necessary to, you don't have to have one. It helps if you have a lot of snow, is a snowboard. It's basically just a piece of plywood, about 16 by 16 inches is pretty good. And you paint it white, just get some spray paint or whatever, some leftover paint. And white, reason why white is it doesn't heat up, it doesn't melt the snow. So it basically preserves the high reflectivity, so it stays cool. And just put that outside. And basically the reason why we use a snowboard is it's a nice solid, in order to measure to put your ruler in, it hits the board and we know very accurately the depth. Whereas if you just stick it in the grass may start, and the grass may be this thick, you can push it down, you may have a plus or minus of an inch, because it depends on how hard you push the yardstick down. So this provides a nice accurate way to measure snow. So, but it's not, you don't have to have it. You could use like a table or part of your house that's open. I actually use that. I did a study and I actually used the stairway where my house is. It actually has the highest amount of snow there. And it was even higher than my snowboard. So I said, okay, I'll use that. And so find out an area where it doesn't have the snow doesn't artificially settle there, but it's far enough away and close enough so you can actually get to it when it does snow. So this is sort of a guidance on it. It's using snowboard is fine. You don't even have to paint it if you don't have paint, but it helps too. So when we import snow, always look at the forecast and say, oh, it's going to snow. So I'm going to remove the funnel. Because why? Because if you get like 3 or 4 inches of snow, it's just going to pile up like this. It'll just look like a big snow cone. And then you're not going to be able to get a good catch measurement of snow if you have looks like a snow cone, because there could have been snow coming down and falling off. So what you want to have it is open cylinder, and then just put all the funnels and the inner cylinder in your house while you wait for the snow. And then what you need to do is when the snow comes in the morning, you'll need to take the snow, and I usually bring it inside my house and melt it. So you could, if you're really patient, and if it's not snowing out, you can just wait for the snow to melt. However, I'm never that patient. So what I do is I fill up a cup of hot water, so not like boiling, but hot enough, so like maybe hot enough that you can drink for a tea. Put it in the microwave for a couple minutes, and so use that, and then you use that to melt the snow. But before you put it into your snow, you'll need to measure it exactly how much hot water you're going to add to melt the snow. So in this example here, I heated water in my cup and I put in 0.94 of non-precipitation. This is just to melt the snow. And I measured it with the inner cylinder, measured it very carefully with the inner cylinder and wrote it down. So that's I need to subtract that amount from the precipitation, because it's not snow. This is my cup of hot water. And then I added that to the outer cylinder and I swished it around. And it took 5 minutes. And so all the snow is melted. So it's like a wet snow cone, and you make it so it's all liquid. And then the goal is to have it completely all liquid. And then you'll do the same thing as when you get more than 1 inch. So you'll pour in the amount of snow melted into here. And sometimes it'd be more than this example here. I had to do it twice. And so I calculated, I added in the 0.91, and these are all the actual snow measurements, 0.91, 0.87, 0.84, and that was 2.62. Then I also added that 0.94 of just the hot water from my spigot. So I had to subtract that. And that's actually the amount of snow water is that 1.68. Does that make sense? Let me move this so I don't spill it. Okay. So it's just an extra step, but it's really important because that's your precipitation measurement for the day. And so that's what you enter in. So this is the form that you enter in for precipitation. So normally you'll put a liquid amount from the rain. And so if it's liquid, you'll enter it here. You never put the actual snow depth in there. You put the snow depth down here. So that's what another second most error is, to put how deep the snow is into the melted. And that's something we have to correct after you submit it. And you can always edit your submissions afterwards. But I see that a lot because I sometimes will see like 11 inches in the melted, and it's, oh, they just have them switch because we don't have 11 inches of rain in New Mexico, not like they do in, say, the New Orleans or somewhere in Florida. So this is the melted amount, and this is the snow depth down here. So that's how we do snow. Okay, so I want to do the rest of the time is talk about, so how do you use the website, because that's sort of the nuts and bolts of what we do, and how to record your observations. So this is our website again. It's fairly informative and fairly easy to do. Once you are logged in, once you have a username and password, you'll click on this My Data right here, and you'll click on that, and you'll get this this part of the website will become active, and you'll have, like I have it saved on my browser, my username and password. It saves it on my computer, and I also have it saved on my cell phone, so I don't have to keep entering it in every time. And then once you click that log in, you're ready to enter your number in. It's that easy. And so this is on a day-to-day basis, it'll automatically open up to this page, and say you already looked at your gauge and it was 0. It's like no rain, it's drought, nothing outside. So it automatically will populate your preferred observation time, and automatically puts in a default 0. So if that's the case, all you have to do is say, yep, I'm done, submit data, click, and you're done. You can go about the rest of your day. And same way with the app on your phone, it does the same thing. It even actually the app actually tells you what the current time is. So if you're out at your gauge, you could actually enter in the number right there at the gauge. And sometimes I'll do that if I'm tight, if I'm crunched for time, I'll just go there and enter in and just take care of it all right there, and don't have to go on my computer. So that's how you enter in your daily precipitation. Very simple. So just remember, this part of the website right there, that's the liquid amount. So that's your liquid amount. So normally on a non-snow day, that's going to be the amount of rainfall. If it's a snow day and you melt the snow, that's where you put the liquid amount, the melted part. And remember, melted, and then the depth is here. This is your snowfall. So when you go out and measure it with your yardstick, you'll put the number of inches in tenths. So, and you can always click on these little help to kind of remind you what those are, if you're confused. So and we also appreciate comments. So we get a lot of comments, and I have a student that looks at the comments and puts them to social media. And so there's lots of funny things as well as very useful things, in terms of some people put their temperatures. They have a weather station, so they'll actually type in the relative humidity, temperature, or they'll put in something like it was so much snow that I couldn't get out of the driveway, or it was so cold I had to put the horses, take them out of their corral and put them in some other area where it's sheltered. So things like that. Or it's been so dry, we've had lots of fires and there's smoke everywhere. It's anything you would like to put that you record, something that's on your mind. We'll read them. You can put whatever you want on there. You can put numbers, text, things like that. It's your notes, and then you can go back and look at your notes if you're kind of remind yourself what the weather was and stuff like that. So it does save all this. So that's your comments. And when you're done with that, you just hit the submit data, and you're good. Then you're done. You've got it all. And you can, once you submit it, you can look at your own data. So you can list my reports. You can even look at other people's reports and map it. So like here's, if you click on the static maps, I just chose a random date and location. You can actually see where all the observations were. So this was back in 2018. I just chose just a random day, and there was in Apache County, there was an observation there. And if you click on the county, it'll actually show the amount. And then we have two different ways to look at maps. This is the static map, and we also have a dynamic map, which uses like a Google interface. So you can zoom in to a certain extent. We try to keep some privacy to the observations. So it doesn't zoom in all the way to see where you are, but it gives a sense, the community that you're in. So it'll actually show a number on a day-to-day basis, and it'll show all the observations in the country when you look at the dynamic map. So this is just a way to view data and to see where it rained that day and where it didn't rain that day. And so that's pretty much all I'm going to show right now. I think I'm going to try. Let me just finish up with this slide. So you can find out more information. And if you're interested in joining us, Helena is at the Climate Hub, our contact for tribes, and I cover all the rest of the state. And so contact Helena. I can't speak for her, but there may be some opportunities to get gauges. I have a very limited amount of gauges. I have just a few. I mainly give them to people who have been observing for more than, say, 10 or 12 years. And sometimes the gauges get all clouded up. Like this one has been outside since 2011, and eventually they'll start to break. Like this one has a big crack in it. So I've been providing gauges to those people who've been doing it for many years. I also there's a website there below my email. That's we have maps there to provide to look at the amounts over time. And if you're already a CoCoRaHS volunteer, I just want to say thank you for coming out and joining us and helping us create a great product for the country. And so one of our things we say is every drop counts. And so I will leave it there, and I'm going to show you if I can. Let me just stop sharing a minute here. The live website. Let me see if I can do that. But we can take some questions while I do this.
So Dave, there was a question from Michael. He asked, the hail size is in diameter, correct?
Correct. Yeah. Can you guys see this? This is the website. I'm assuming you are.
Yes.
Okay, good. So if you click on the dynamic map, this is live, so who knows what's going to happen. So this is today's observations. So here's, if you look at, there's very few. We need some more observers in the Four Corners. We have very few out here areas. So here's like Santa Fe, Albuquerque, we've got quite a few. And then the rural areas, we really need to get some more observations because we use this to create maps of precipitation. So let me go back. So you can actually go and get their data. So these are all the actual values. Let me just do one, for instance. Here I just had just one. Let me go back in time. So you can go back and look at, whoops, there's nothing for that one. Let me just type in mine. These are all my observations where I took. So you can go back and look at the mapping, or you can view the observation. So this was I had trace amount on my gauge, and you can go back in time. Just click on the start date and see what you measured, and then you can actually go back and do a sum too. You can export it to like Excel if you want to, or you can go back. And I as the coordinator, I like to look at these map. I do a query of the number of observations for the whole state, and like for instance, here's for February 18th, there are 429 reports for the whole state of New Mexico, and the maximum precipitation, these are liquid amounts, was 0.94, and the average was 0.06, so 0.06 of an inch. Let me just kind of show you so this is actually, let me use my other browser because this one doesn't save my login. So I just want to kind of show you what it looks like. Share screen. There we go. So here's mine. So here's if, say I wanted to report something else. So like hail. So I'm reporting hail. So this is live on this is my station. So say it was some hail came in at 4 p.m. And I noticed that it was the smallest was pea size and the largest was grape size. The average maybe 3/8 minutes, and it lasted for 5 minutes. If that's my observation, I just hit submit, and they would go to CoCoRaHS, and it would also go to the National Weather Service office, and so they would actually get that observation, and they use that to say, oh, it's hailing somewhere. I'm going to look at the radar and see how this hail jives with the radar. So it's a way to get that information. And so, for instance, another question too I've gotten is, what if I'm not there every day? So I'm out of town, or I can't get to the gauge. You can do a monthly zero. So I haven't entered in my value for yesterday, but if you could actually click on that and say, oh, I did read the gauge, but I didn't have time to enter it into the website. So I just click that and then hit submit. And well, that's one way to enter in data on a whole week or several days. Or you can do this thing called a multi-day. So if you missed a day and you actually didn't look at the gauge at all, it's like, oh, I couldn't make it because I was out of town or I was sick, I didn't get outside. You could actually do a multi-day. You measure it one day and then you say, oh, I was sick for 4 days, so I didn't measure it until that one day. So you don't know, and it was rain in the gauge when you got there after that 4 days. You could actually enter in that amount here. So say that there was 0.05 inches when you got there 4 days after your last observation. You just type in the day, the first day of accumulation, and then when you read it, when you emptied it, and then hit submit. So this is one way to do it. It's a multi-day observation, and that's fine. We take whatever observations you can give us, and we actually use on our mapping. We do those multi-day as well as the every day to sum how much precipitation fell over, say like a week, a month, a year, and so we'll do we'll actually do the math for you, and then total and make maps that way. So that's one way to that we really would help us out to do that. And here I just want to click on the training. So if you click on that training, you can actually go, there's PDFs to basically this presentation here. The one that says get started, that basically is very similar to what we just talked about just now in the last 40 minutes. And then over on this to the right of that, there's in-depth snow measurements. So if you totally forgot about how to do snow, you can download this PDF and save it, and then go through the snow and go through how do I actually do this. And there's a lot of things you can say. If you get like ice storms, how to actually do the observation. And you can do this thing called condition reporting. So we actually do that as part of the CoCoRaHS condition reports. You can, as you're a member, you could actually submit a report, and you could click on here. You could say, okay, at my backyard or area that I work in, is it severely dry, moderately dry, mildly dry, or above average, wet? And then you can click on some text. You can type in something, even my cottonwoods are dying. You can type that in if that's what's going on in your yard. And then what are your reports? You would, if your cottonwoods are dying, you would say it's plants and wildlife and maybe agriculture or something, depending on how much it's spread out over your backyard. And then you hit submit data, and that goes in, and then we map that. Let me just show you that. We put the US Drought Monitor as the background, and then all the reports, and this is the whole country. So let me zoom into our neck of the woods here. And so each of these little triangles are observations from people. So here's one. It says state hydrological tech here, Wednesday in community, well, aquifer down 16 feet, water very hard, highly mineralized. So that's a drought impact. There's an observer, looks like up by Aztec up here, rain yesterday, then snow, moisture in the mountains will be good as it fills the rivers. So there's sort of a, it's an observation. And then we've got other folks just north of Roswell, talking about how bad it is in terms of, things are dormant, but there's very little feeding going on with the cattle and the rangelands. So this is part of CoCoRaHS, and it's being used not only to measure precipitation, but the drought impacts. So this is called condition monitoring, and it's used. Let me go back to the CoCoRaHS page here. You enter in on once you're logged in, you connect. So this part of the website is this is where you enter in your information. There's a line here called condition monitoring report, and that's where you enter it in. So it's very simple. And then also we have the Android, the app. I have it here. I don't know. You probably can't see it. Let me try to bring it up because it's probably my camera. But that's the app ready to go. It's probably hard to focus in on it, but I have it set up with my username and password to so I can enter in data for. So I'll stop there, and then if there's any other questions. So like I said, this is complementary to the rain log that Mike Crimmins gave. There's different users for different types. So if you can't get to your rain gauge every day, or you can only get to it, say, once a month, you put them out pretty far away. You can take a horse and go up there. This may not be the right program, the CoCoRaHS, because if you leave the precipitation in the CoCoRaHS gauge, it'll eventually evaporate. Whereas the gauges that Mike Crimmins has, there's oil, and it actually prevents evaporation. And so those are really good for if you want to just leave it out there and collect precipitation over time. Whereas the CoCoRaHS, it's designed to be collected on at least every day to every few days, because there's a little bit of evaporation. The hole is small, but there's still a little bit of evaporation that'll occur out of this gauge. And we typically don't put oil in here because there is an inner cylinder that would mess up the measurement. Whereas Mike Crimmins, his is designed to be used over long periods of time, which is great. So there's two different ways. If you have a ranch and you want to put one pretty far out and you just want to know how much rain fell over this month or year, you could go ahead and create one of those rain log. But if you're by your house, you could run a CoCoRaHS gauge, and you can report that every day or every other day, depending on how often you actually get to the gauge. So there's different ways, and if you have extra money, you can even get an automated gauge. We don't use automated gauges in CoCoRaHS. We only use these manual gauges, the 4-inch diameter for CoCoRaHS. But you're welcome to get an automated gauge, and those can be, especially if you have internet, those can go online and then be used for other users, and you can look at it over time. So there's many ways to get connected, collecting weather, and weather stations. They do temperature, humidity, winds, and things like that. Remember, this is only precipitation, and we also do drought with this too. So I just wanted to make that comparison between the two observation programs. They're both they both have their own uses and type of users.
Okay, we have two questions from Michael. Hill size is a diameter, right?
Correct. Diameter.
Okay, and then we have one from Sadie. What is the cost of a CoCoRaHS?
Okay, so it's right around, let me click on the website. I'm assuming you still have this. Here's one of the vendors. There's several vendors. And so right now, this is the gauge right here. I clicked on it. So it's $32.75 for a gauge. And then you'll have to add shipping, whatever the shipping. If you want it really quick, you'll have to pay more. But that's the cost of this gauge. And there are other vendors out there. Let's see. but it's about $30 to $40, depending on how much shipping costs. There are other suppliers, which I don't see that here. But yeah, it's about $30 for gauge and then shipping. And I don't know, Helena, is there something you want to mention in that aspect?
Yes, so through the Southwest Climate Hub, we do have some CoCoRaHS rain gauges. And I believe through the NAPS program, I believe they'll be working with their producers to get them connected with the CoCoRaHS network as well.
Do we have any more questions for at this time?
I have a question.
You have a question?
So is there an easy way for an observer to upload past data, like say for the past few months?
So assuming you already have an account, so like here's my account, I could go in, I can edit mine. There's not a really easy way. If you have, these are all the things I've entered. I would have to go in and manually type in the numbers. And so what you could do is enter in the precipitation numbers and this way. And right now that's the only way to enter in. Say you had a month of observations, is to enter them in. And I've actually had to do that because there was a couple people who didn't have internet. So they wrote it on a piece of paper and they put it on my desk and they wrote all the numbers and I entered them in for them. And I was wanting to know the same thing, but right now there's only one way to do that, is to manually go through. And then if there is actually a zero, you measured and it was nothing there, you can go back and do the monthly zeros and just click on the zeros. And of course you don't want to click if there's actually measurement there, of non-zero. But yeah, there's not a good way to automatically just type in. Maybe in the future is to go and enter in like a spreadsheet or something like that. But yeah, that's a good question.
I have
Okay,
an observer who has a year's worth of data they have not yet entered yet. And so I'm looking for volunteers to help me. I'm just kidding.
Let's get it in. Let's get in. Do we have a volunteer to type it in for you?
Okay,
Buy you
well,
a
it
candy
looks like
bar.
we don't have any more questions, but we have a departing from Michael Patrick. He says, great presentation, Dave. The NAPS project will look into the recruiting and supporting volunteers on the Navajo Nation to participate in the CoCoRaHS network.
Wonderful. Thank you.
Okay, I believe we're done with questions and answers. So at this time, I will turn it over to Sadie Lister.
Good evening, everyone. Just wanted to add to what Michael had indicated that Sharon read. What we'll do and would like to do is help producers who are interested. If you purchase a CoCoRaHS or maybe receive one from Helena, we do have a staff of 4 who are willing to help you download the app, help you to go through the app to make sure that you understand the data, inputting the data, and then even to help you work at installing the CoCoRaHS on a post near your home. So we'd like to do that, and we also have a poll that we'd like to conduct. So if you're interested, we will have contact information here in a bit. You're welcome to contact us. Okay,
Okay, at this time, we will wrap up
hold on, Sharon. There is a question that,
and have, oh, okay.
yeah, it says, where are these sessions stored? May got on late. So May, what we're doing is we're recording the webinars, and what we're going to do is put it into a video format. And if you look into Native American Producer Success Project NAPS on Facebook, you're able to access the webinar there, or you can go on YouTube, also looking up Native American Producer Success Project NAPS, and you'll be able to find it there just as well. And thank you for joining us, May. It's been a while.
Okay, at this time, we will wrap up and have poll questions posted. If you can answer these questions, and it'll help us out a lot on what we can bring to these webinars. I can't participate.
There's a question from Ernest. He would like to know if we are trying to get more locals to collect data. Yes, we are. We'd like to see if we could recruit some producers on Navajo Nation to get on the project. Like Dave showed on his screen, you know, there wasn't very many. There actually, I think there was only one out in the Page area. So I think this is a good idea.
Okay, there's another question. Interested in oil field rain gauge for remote area. NAPS can help.
Mike Crimmins presented on the rain gauge for the range. He will be sharing with us a link where we can purchase the items, or where you can purchase the items to build the rain gauge for your rangeland. And like I said, you're able to get on our webinar and listen to it, and then it'll give you a lot more information.
Hi, Ernest. This is Helena. So we had originally planned a rangeland precipitation monitoring workshop in New Mexico, and we're planning one for Arizona in the future. And so these are a do-it-yourself rain gauge. It's a cumulative. It's made out of PVC pipe. So if you'd like more information, if you could share your email with me, I can send you more about that.
And anyone else interested, go ahead and add your email for Helena. Thank you.
Okay, thank you, Dave, for such a great presentation on this CoCoRaHS. We appreciate all the information you shared with us and hope to see you again on a webinar.
Thank you.
Please join us for our next week for our last webinar in the series at 5:30 p.m. Mountain Time. Our speakers will be Crystal Tully Cordova, Navajo Nation Department of Water Resource, and Nikki Tully, University of Arizona. Like and follow us on Facebook, where we post information about upcoming events, monthly newsletters, how to video, USDA resources, and link. Recorded webinars will be posted on NAP's Southwest Climate Hub website, NAP's Southwest Climate Hub YouTube, and NAP's Facebook. Thank you all for joining us. We'll see you next week at 5:30 again. Good night.